You'll notice that I'm skipping example 5. Once again, this set of notes went to printer before I was able to confer with other advanced topics teachers and or pre-calculus teachers and realize that example 5 is more of a pre-calculus kind of problem, so you can struggle through that next year. Have fun. In example 6, notice that the title of the example says solve exponential equations in quadratic form. So notice that we can bring this 8 on the right hand over to the left, and I'll have e to the 2x plus 2e to the x minus 8 equals 0. So the book shows you one way of factoring this out. It has you replace e to the x with just n, and then factor it from there. If that makes you more comfortable, then go ahead and do that. But I think that you can handle thinking of this as e to the x and e to the x, and if I multiply e to the x times e to the x together, I get e to the 2x. And it factors exactly the same way everything else does when it's in a quadratic form. We're looking for factors of 8 whose difference is 2. So that's 4 and 2. I want the 4 to be positive, and I've factored it. Now I just need to solve it. So I know that e to the x will equal 2, or e to the x will equal negative 4. And at this point, since it's e to the power of something, you want to take the natural log of both sides. So the natural log of e to the x will equal the natural log of 2. Natural log of e to the x will equal natural log of negative 4. And remember, since natural log is a log of base e, then that means that x will equal the natural log of 2, or x will equal the natural log of negative 4. But I hope you realized you can't take the log of a negative number. Try it in your calculator. Your calculator is going to spit back an error. So that doesn't work. X is the natural log of 2. Which is approximately 0.69. We can solve part B in very much the same manner. Get the 5 over to the left-hand side, and we have 4 e to the 4x plus 8 e to the 2x minus 5 equals 0. And when I put my numbers into the parentheses, you're going to have e to the 2x and e to the 2x. But before we do that, let's think about these numbers first. Because I have a leading coefficient this time, I need to think more carefully about what numbers I'm putting where. Remember that you multiply a times c, so 4 times negative 5 is negative 20. And I want to break that up into factors that will add up to 8. So that's 10 and negative 2. Well, 4 isn't a prime number, so I'm not going to put anything in these spaces yet, but 5 is. So I know there's only one way I'm going to get that 5, and it's with a 5 and a 1. We'll worry about the signs in a moment. Remember that the 10 and the negative 2 are our inner and our outer. So 5 times something has to equal either 10 or negative 2. Well, it's got to be 10, so that means that this will be 2e to to the 2x, and that means that this has to also be 2e to the 2x. I want the 10 to be positive, so that means I want the 5 to be positive, and the minus sign goes in the other parenthesis. And now I can go ahead and solve for x. So I have 2e to the 2x plus 5 equals 0. Or 2e to the 2x minus 1 equals 0. In this first equation, I would have that e to the 2x will equal negative 5/2. And if you look at the last example where we ended up taking the natural log of a negative number, or trying to, and we realized, well, that doesn't work. This doesn't give me a solution. Let's solve the other one. E to the 2x would equal 1/2. So when I take the natural log of both sides, I end up with 2x equal to the natural log of 1/2. So that means x is the natural log of 1/2 divided by 2. Plugging that into your calculator, we have negative 0.35. Here, once again, we can use the one-to-one property, but we must condense first. When we do, we have the natural log of 7x plus 3 over x plus 1 equal to the natural log of 2x. So I can simplify this equation and have 7x plus 3 over x plus 1 equal to 2x. To get the x plus 1 out of the denominator, I'm going to multiply both sides by x plus 1. Keeping in mind that the whole reason why we're doing that is so that it cancels out on the left-hand side. So if you were looking at that thinking, ew, FOIL, no, it cancels out. So you have 7x plus 3 equal to, now you do have to distribute on the right-hand side, so you get 2x squared plus 2x. And we do have a quadratic here, so we want to bring everything over to one side. I would advise bringing everything over to the right-hand side. So that means I have 0 equal to 2x squared minus 5x minus 3. And now we factor this trinomial. I know it has to be 2x and x because 2 is a prime number. When I look for factors of 6, and I get that 6 from multiplying the 2 and the negative 3. When I'm looking for factors of negative 6, rather, that add up to negative 5, I know I want a negative 6 and a positive 1. So 2 times this is going to give me either negative 6 or positive 1. It's going to be negative 6 when I multiply it by that negative 3, and the positive 1 goes here. And now I solve for x. So x will equal negative 1/2, or x will equal 3. Now, if I plug in that negative 1/2 into my original equation, a flag should go off in your mind that on the right-hand side, I'd be taking the natural log of negative 1, and that's impossible. So this is not a solution. If I plug in the 3, Nothing wild and crazy is happening. I'm not dividing by 0. I'm not taking the natural log of a negative number. So x equals 3. You might want to pause the video for a moment so that you copy everything down before I erase in order to do part B. Natural log of 2x plus 1 times 2x minus 3. You will have to FOIL that. I want to use the power rule on the right-hand side and get the natural log of 2x minus 2 squared. And you'll have to FOIL that out as well. So let's drop the logs now out of the equation. And I have, let's go ahead and FOIL it out too while we're at it. 4x squared minus 4x minus 3 is equal to 4x squared minus 8x plus 4. And oh, this is convenient. I don't have a quadratic equation here. So I'm going to add 8x to both sides and have 4x. I'll add 3 to both sides and get 7. So x is 7 over 4. And when I plug that in anywhere, I don't see any instance where I'm taking the natural log of something that's not allowed. So it looks good. The last kind of example, this one says check for extraneous solutions, but I hope you realized we checked for extraneous solutions in the last example as well. In part A, we will condense and have natural log of 6y plus 2 over y plus 1 equals natural log of 2y minus 1. I can drop the natural log out of my equation and have 6y plus 2 over y plus 1 equal to 2y minus 1. Like in example 7a, multiply both sides by y plus 1 to get your variable out of the denominator. It cancels out on the left-hand side, so I have 6y plus 2 equal to, we have to FOIL out on the right-hand side, so that's 2y squared plus y minus 1. I have a quadratic with some y terms, so let's get everything over to the right side of the equation, giving me 0 equal to 2y squared minus 5y minus 3. When I factor it, I know I have 2y and y, because 2 is a prime number, and there's only one way I'm going to get that. 2 times 3 is negative 6. I'd be looking for factors of negative 6, who add up to 5. That would be negative 6, see the negative 6, and positive 1. And then we solve for y. This would give us that y is negative 1/2, or y is 3. And once again, if I take that negative 1/2 and plug it in on the right-hand side, is where I notice it most immediately. When I plug in negative 1/2 for y, I get negative 1 minus 1, so I'd be taking the natural log of negative 2. That's impossible. So y is 3. last example, part B, a little bit different. Before I go condensing anything or getting the logs out of the equation, I need to get them on one side of the equal sign, and here's why. That's the fly in my ointment. Okay, so this one's going to be a little bit different. I'm going to subtract the log of x minus 2 from both sides, so I'll have log of x minus 12 minus log of x minus 2 equal to 2. And now I'll condense it. Log of x minus 12 over x minus 2 equals 2. And at this point, I can't drop the logs from both sides of the equations because I don't have logs on both sides of the equation. What I can do is remember that when I see the word log and I don't see a base, base is 10. So we could actually rewrite this in exponential form and then solve the equation from there. So it would be 10 squared equals x minus 12 over x minus 2. And I still want to multiply that x minus 2 from on both sides. So I'll have 100x minus 200. Because I'm distributing the 100 that is equivalent to 10 squared. These cancel out, and I've got x minus 12. Well, this is wonderful. I don't have a quadratic. Well, goody. So this is 99x. When I add 200 to both sides, I have 188. Dividing both sides by 99, x equals 1.90. And if I take this 1.90 and plug it in here or here, I'll be taking the natural log of a negative number. It's not allowed. So this equation has no solution.